Go.
So we are Bays Unlimited. Over here we have our demand curve. And basically when the generation minus the demand is greater than 0, we will be charging. And when the generation minus demand is less than 0, we will be discharging. And the only time that we will not be charging is during the peak hours between 3 and 8 p.m. because that would only add to our demand curve.
So the basic idea of this demand curve is to show the amount of electricity that a consumer would use at an average house. And this blue curve here represents the solar generation peak time of the day. Most cases will have solar generation being above the demand curve when it is the middle of the day because that is when people are using less electricity in their house. So we want to store that electricity and be able to use it at the peak time, which is why we will never be charging from 3 to 8 p.m. We want to be able to take a certain percentage off of the consumer's peak demand, which is something that they would relay to us, so that we could then find the correct size of the battery and the size of the solar panels for that certain residence. So we can adjust their demand curve to that new amount, which will be using that stored energy to decrease and lower their electricity bills.
This is what a typical house would look like without, obviously, this part and the solar panels. But if we do this product, our product would be right here. That's the Recurve Solar microprocessor. The battery, the inverter, the house panel or meter is located right here as well, and the solar panels.
So we've had some questions. Why is a battery going to be the electrical battery be the best solution or ideal battery for solar? Why not use some sort of compressed energy or other thing? Well, we have a couple of other solutions here. A supercapacitor, compressed air, thermal, and then our actual battery here. But the real problem is with the supercapacitor, they use these on things that on more computer things that really need a little slower, they work on a faster pace. So they don't discharge over a long period of time. They discharge really rapidly. So it's not something that's very practical for something like this. It's not going to discharge a very long time. Then we have compressed air. Compressed air doesn't work because it's not very practical. But in homes right now, there's not something that would be able to just have compressed air held for that long. And the same thing with thermal, unless we want to have some sort of big tank that we want to drop into their house, it's not something that's really going to be very easy to implement. So that's why the solar battery is going to be the most ideal solution for the Recurve Solar, and that's why Recurve Solar, we're putting so much effort into it, because it's honestly going to be the most ideal solution for solar generation.